In order to find an arc measure, so let's say in this particular case we have circle Y. Okay, remember, you can name a circle by its center if there's no other circles that have that center. You want to find the measure of arc XZ. Okay, remember, arcs are measured in terms of degrees, the same as angles, and the relationship that we use to find an arc measure is that the measure of an arc is equal to the measure of the corresponding central angle. Okay, so when you're looking at the intercepted arc, so in this case XZ, the arc measure of this is going to equal the central angle measure. So in order to find this, what you would need to do is identify its central angle. So using measuring tools, okay, you may have to, and this is especially true for the construction worksheets, okay, if you wanted to find an arc measure, can you tell based on this image here what is the arc measure of XZ? So it looks like it passes through right here. It says 70, 110. Which number is it going to be? 110. Okay, again, be very careful of that. So we see that since this angle measure is 110, the central angle measure is 110, the corresponding arc measure also going to be 110. Okay, so that's how you'll find those if you're looking to solve for them. Okay, what if I asked you to identify the measure of arc XWZ? Again, in terms of degrees, what is that arc measure going to be? From X through W to Z, so now it's the major arc. And so to find it, you'll just take 360, the full rotation, subtract the central angle, and that's going to give you this reflex angle right here, which is 250. And therefore, this major arc has an angle measure of 250 degrees. Okay, so that relationship will hold true for all circles and all arcs of circles. Okay. Are there questions about that, just finding the arc measures? Right, a couple other just relationships to look at, and that is if you have two circles, okay, it's possible for circles to intersect at 2 points. Is it possible for circles to intersect at one single point? Okay, so here would be a case of these two circles intersecting at one single point. Okay, so these are called externally tangent circles. Okay, it's just describing the relationship for those. Okay, it's also possible, though, for two circles to share one common point in what's called internally tangent. Okay, so these terms are describing the relationship here. The internally tangent circles, one circle is completely embedded within the interior or inside of another, and here the circles share no common points. So all the common points of one are within the other, and in the externally tangent, no common points other than the point of tangency. Okay, and then finally, you could also have pairs of circles that don't intersect at all. So you can have one intersection, two intersections, or no intersections. Is there a way to have three intersections between two circles? No. you're either going to have 1, 0, or 2, and that's it. Okay, now, if you have two circles or multiple circles that share the same center, again, just terminology-wise, okay, so if we have these set of circles, these are called concentric circles. And the word itself builds on. The prefix con means with or within, or with the same center. Okay, so concentric circles just have their circles with the same center. So can we name a circle? Could we call this circle A? No, because you don't know which one you're referring to. It could be the inner one, the middle one, or the outer one. So when you have concentric circles, you have to name the circles based on 3 points along the circumference. There's no other possible relationship.